Okay, so this is salt hydrolysis. There are 3 levels, easy, medium and hard sort of questions. So let's look at the easy ones. These are mostly multiple choice. So I'm going to write down 4 salts. And when you see the salts, you have to decide how they could be made. What combination of acid and base would make these salts? And once you've decided that, it's quite easy to work out if the pH is acidic, basic or neutral. So the first one is potassium nitrate. Potassium nitrate could be made from potassium hydroxide, a strong base, it's group 1 hydroxide. And the NO3, the nitrate, comes from nitric acid. So that's a strong base, strong acid combination. Calcium hydroxide is a weak base. It's not a group 1 hydroxide or barium hydroxide. And nitrate, again, is nitric acid, a strong acid. So that's that combination. Sodium hydroxide, strong base, and that's methanoate, so that's methanoic acid, a weak acid. Ethanoate is a weak acid, and ammonium's a weak base. So I've worked out what acid and what base could be used to create each of these. So the trick is the pH goes towards the stronger component. So for calcium nitrate, it goes towards the acid, so it's below 7. And for sodium methanoate, it goes towards the base, above 7. It goes towards whatever the stronger one is that you use to make the chemical. For medium ones, well, these are kind of paper 2 questions where you need to explain why that's the case. So I'll choose calcium nitrate as an example. There's a pretty standard way of writing it out. Show the dissociation of calcium nitrate. It's completely soluble nitrate, so 100%. And then underneath, every time you need to write out the dissociation of water. That's an equilibrium. And now you've lined them up in this way. You can see that calcium hydroxide is actually a weak base. So hydroxide and calcium want to stick together. So the hydroxide will be removed from the solution and permanently bonded to the calcium. And that's really kind of nitric acid. Nitric acid's a strong acid. So as a strong acid, it wants to be 100% dissociated. So overall, there's more H plus in the solution, and there's less OH minus. That's been removed, stuck onto the calcium ions to make calcium hydroxide, which is reasonably insoluble. It's a weak base. Let's look at another one. Sodium methanoate. So that breaks up completely to form sodium ions and the methanoate ions. And again, we're in water, so I'm going to show the dissociation of water. That's an equilibrium. And I'm lining up my charges like before. Now, sodium hydroxide is a strong base. It's 100% dissociated, so that hydroxide doesn't want to bond with the sodium. But the hydrogen ion and the methanoate, that makes a weak acid. And I'll draw the equation out. You can actually see that they will react together. Now, where does the balance of this equation lie? Well, almost all of it is 99% combined. The H plus has been removed and permanently bonded to the ethanoate ion. So this is now a basic solution. The H plus has been removed to make a weak acid. The OH minus hasn't. And if it could be any harder, here's a hard one. Let's look at a sodium, which is big, sodium ion, a magnesium ion, and then an aluminium ion. The aluminium ion is very tiny with a high charge. It has a high charge density. But sodium, it's very big with a low charge. It has a low charge density. Water isn't really even particularly interested or attracted towards the sodium or the magnesium. There isn't a big enough electrostatic difference. But the aluminium is very, very tiny, the ion. It's +3, so it actually will rip electrons off of water. Will actually rip the electrons off of the hydrogen-oxygen bond and put it onto the oxygen. And so what's going to happen then is that those electrons have been transferred to the oxygen, which is going to go next to the aluminium, and the H plus comes off. So since the aluminium ion is causing H plus to come off, it's actually going to be acidic in water. It pulls the oxygen, the hydrogen, and the electron pair towards it, thus releasing the H plus. The 3 ions in the syllabus that do this, and the IB want you to know it, are these 3 here. They're all very small with a high charge. So they have a high charge density and they're acidic in water. Whew. That's pretty tricky to understand, eh?